This is the one that's given to you over and over and over again since probably 6th grade or so. Slope-intercept form. What is that? Taylor, your arm was up, wasn't it? Perfect. Okay. So slope-intercept is the slope, M, the intercept, B. Okay, one that you don't work with as often, but it is equally valuable, point slope form of a line. Does anybody remember point slope form of a line? Taylor, you got it? Correct. So you're given some coordinates, and that coordinate you're given is some x sub 1, y sub 1. So they'll give you an x, and they will give you a y, and they might give you a slope or ask you to find slope. But just like y equals mx plus b, we know the y stays a variable and the x stays a variable. And point slope form, the first y stays a variable and the first x stays a variable. So you might have something that might look like, an example would be y minus 2 equals 5. Oh, y minus 2 equals 5, x minus 3 or something. Like your equation would look something like that. That y and x stay as variables. But the y sub 1, x sub 1, pay attention to the signs. It's y subtract y sub 1 and x subtract x sub 1. And so as you're filling in your coordinates, make sure you're paying attention to the signs. Third one, what is an equation for a horizontal line? Am I going to start out y equals or x equals for a horizontal line? Y. So this could be like y equals 2. That would simply be a horizontal line through 2. So y equals 2 creates a horizontal line. And if we had x equaling 2, that would be a vertical line. So those are a little counterintuitive. Sometimes you have to think about that. X equaling means that x has to be this number. So I'm essentially on this vertical line. All my x values are the exact same. It creates a vertical line. Horizontal line, all my y values are the same. And it asks for an equation, so that's why we have the equals. So y equals or x equals. 4, for two lines to be parallel, what can you say about the slopes? What would the slopes be of parallel lines? Mason F, what do you think? Nope, for them to be parallel, what could you say about the slope? So if I had two lines going on, what's that? Exactly. Okay. Nope, that's not very, very good. That's a little better. Okay. So if they're parallel, they have the exact same slope. Doesn't matter how much shift was going on, the slope remains the same. The y-intercept could change or will change, but the slope will be the same. Perpendicular lines now create a cross section, and those have what? What can you say about the slopes for perpendicular lines? Will it be the same slope? No. But what's significant about it? Say one was a slope of 2, what would the other one have? Mason C. Okay. So opposite sign. So the opposite sign, if it was a positive 2, it would then become a negative. And then also the reciprocal. So it was a slope of 2, it's now going to become negative 1/2. Okay, so the opposite sign and the reciprocal slope. Okay, so let's practice these. So find an equation from the graph. So using this graph right here, what is the y-intercept, Dayton? Okay, so the y-intercept is -1. What's the x-intercept? Dayton, continue on. -3. Okay. What is the slope of this line? Okay, so it's going to be negative because we know it's going from top left to lower right. And remember, slope is rise over run. And so this one had a rise that essentially went down 1. And then the run, and then the run is going over 3 units. So that's how we get that negative. So it's a -1 all over 3. So my slope would be a -1/3. Okay, same graph. Now write the equation in point slope form. So again, point slope form is y minus y1 equals my slope x minus x1. So on this one, I simply just have to choose one point on the line. Okay, doesn't matter which point I choose, but I have to choose one point on my line that I'm going to fill in. Allie, give me a point on the line. What is it? Well, a coordinate point. There you go. So 0, -1. Okay. And so if we want to use that, this is my x sub 1, this is my y sub 1. And so I would say y minus a -1 equals the slope we found was 1/3 x minus 0. And you can stop. They asked for it point slope form, done. That's point slope form. I don't have to work on moving the y to the other side and setting up as y equals. I can leave it right like that. That is point slope form. But now if I want to write it in slope intercept form, I need to know, well, I know my slope is 1/3. I need to know my b value, which is the y-intercept. So the y-intercept is -1. So if I know both of those, it's easy enough. I just have 1/3 x minus 1, and I'm done. Next one, write the equation in standard form. What's standard form? We talked about slope intercept form. We've talked about point slope form. What's standard form? We actually talked about this earlier last week too. Hopper, you remember standard form? No clue. Not even the faintest. Taylor, you got it? All right. Perfect. AX plus BY equals C. In these capital A, B, and C, these are numbers. Okay, so the X and Y are still variables. So we want to use this information that we already have, write the equation in standard form. So I'm going to have my X and my Y on the same side of my equal sign, but using only integer coefficients. Okay, integer coefficients meaning I do not want any fractions. Okay, we don't want any fractions, we want just integers. So what causes a problem in part E is that 1/3. So how can I change my slope intercept function to only have integer coefficients, and then we'll rewrite it in standard form? Maddie? Correct. Let's multiply both sides by 3. So I'm introducing this multiplying by 3. I have to do it on both sides. I can't simply do it to one. But the benefit of doing that is now I have 3y. This 3 is distributed on each term. And then my 1/3 x becomes 3 over 3x, which is simply just x. And 3 times the negative 1 is minus 3. But I want to write it in ax squared plus bx plus c, meaning my constant is on one side of the equal sign, and let's write it as a positive constant. All right, so I could move this to the other side by adding 3 to both sides. So I know this equals positive 3 now. And I'm going to move the 3y to this side, so that becomes negative. So I would have x minus 3y equals c. In this case, my c is 3. So that's standard form.
Is it the 1/3 negative 1/3?
Oh, yes. Thank you. Thank you. So this should be a negative 1/3. And so this would be a negative x. And so this would be negative x. So negative x minus 3y equals 3. Good catch. So these are all equivalent equations to represent that line that we have, but being able to work in point slope form, being able to work in slope intercept form, or being able to work in standard form. Okay, last example. Write an equation in point slope form that passes through the point 3, 5 and is parallel to this line. I'll give you a second to write that down. All right, point slope form again. So point slope form, y minus y1 equals my slope m, x subtract x1. So to do this, first thing is we need a point. And then also, we need a slope. Okay, well here's my point, 3, 5, so I can check that off. But I need a slope as well. So this equation, 2x plus 5y equals 4, represents an equation of a line, but my slope is not 2. Okay, so don't make the mistake of thinking whatever your coefficient on x is, that is your slope. If we get it into the form y equals mx plus b, then yeah, then I know for sure it is the slope. So let's transform this into y equals mx plus b. So if I were to subtract 2x from both sides, I'd end up with 5y equals a negative 2x plus 4. Divide by 5 on each term. And I end up with y equals a negative 2/5 x plus 4/5. We'll just leave it as fractions. We don't need to work with decimals. And fractions on the slope are actually easier because then we can easily see rise over run. So on this one, I know the slope of this is 2/5. But I want an equation that goes through the point 3, 5. So now when I write my equation, I'm going to have y subtract the y coordinate they give me, which is 5, equals my slope, which I know is going to be 2/5 because it's parallel, x minus 3, and I'm done. Oh, there we go. There's the line, but we didn't even worry about the graph of it. We already got the key information from it. Okay, now let's do same setup, but now perpendicular. Okay, so this line we knew had a slope of -2/5. So I know then the perpendicular line and some notation would be m sub. So m represents my slope, but then a subscript would be an upside down t. So that's notation for a perpendicular line. So this says the slope of my perpendicular line would be what? The slope of 2x plus 5y equals 4 is -2/5. What would the slope of the perpendicular line to that be? Positive 5/2. So we're going to take the opposite sign, and then we're going to use the reciprocal of that slope. Okay, so again, point slope form, y minus my y value, which is 5. My perpendicular slope now is 5/2, x subtract 3. So this is the equation of the line in point slope form. Goes to the point 35 and is perpendicular to the line that they gave me. If they ask for it in another form, like if they ask for it in slope intercept form, I could go from point slope form and just start distributing. I'd distribute through, I'd move the 5 over. I could rewrite from point slope form into slope intercept form. Okay, and I could also, from slope intercept form, write it in standard form if I needed to. Okay. All right, so 2.5 is in Math Excel. Due tomorrow by the start of class. All this extra practice on working with lines, standard form of equation,